This video will cover different types of definition of acid and base. Here is the Arrhenius definition, a definition that you might have been familiar with from your previous chemistry class. And for acid, it is any chemical or some type of compound that produces H plus, or also known as protons. And base would be something that produces hydroxide ions. For example, if you look at this image, for acid, we have HCl. And when it's submerged in water, the H kind of gets plucked out, and then it forms into an H plus and Cl minus on the side. So from the HCl, this acid is able to produce H plus. Now for base, it says it has the ability to produce OH minus. For example, if you look on this particular image, you have NaOH forming into Na and OH in water. So for acid and base, all of these guys are in its aqueous form, so AQ. Meaning, this particular acid and this particular base are able to submerge in water and are able to split off into its ionic counterparts so that it will produce either H plus or OH minus. This is something, again, that has been introduced in previous chemistry course. But we're going to take a little further and introduce another definition called Bronsted-Lowry definition. Bronsted-Lowry are two different scientists that came up with this particular definition. They realized that some chemicals like NH3, though it has hydrogen, it didn't act like an acid, but rather a base. It didn't have OH, it didn't have a hydroxide, but it sure acted like a base. So because of this particular reason, a new definition has came about. So for acid is a compound that has the ability to donate. It didn't get donated yet, but it has the ability to donate a proton. And a base is a compound that is able to accept a proton or H plus, or also known as hydrogen ion. If you look in this image, you can see how this particular acid has the ability to donate its H to this green compound. So therefore, because it has the ability to donate, this we consider as an acid. And because this green one is going to go ahead and accept it, and you see that in the product, it has accepted it. So therefore, this would be its base. Now, see that Bronsted-Lowry describes this acid-base reaction as a proton transfer of reaction based on where it goes. Now, on the other side of this chemical equation, this acid no longer has the hydrogen attached to it. Then we can label this particular compound as the conjugate base. Conjugate is spelled out conjugate. Whereas this one, the base that has accepted the hydrogen, we consider this side as the conjugate acid. Why this conjugate acid and why conjugate base? This is because this has a double arrow. It is a reversible reaction. If I were to go into the reverse, this guy is able to now donate its hydrogen to this base. So therefore, it's going to react in an opposite direction. And so it's because this is able to donate, this is the acid, and because this is able to accept the hydrogen, it is considered to be base. Now we put the word conjugate to indicate that it's on the product side, whereas the acid and base indicates that it's in the reactant side. Let's do another example. This one is not just small drawings, but rather has a full form, has water plus the ammonia and forming into hydroxide and ammonium ion. So based on what donates and what accepts, what do you think is an acid and what do you think is a base, and what about its counter conjugates? As you can see over here, the hydrogen from the water has been donated to the NH3. So therefore, this is considered to be acid. Whereas this is the base, since it has accepted the H based on the product. Now the product side, the base right here becomes an acid. And because it's on this side, we need to write conjugate. And that acid in the reactant side has become a base. So we write this as conjugate base. Let's do a learning check based on what we have learned so far. Here it says identify and label the bronzyluric acid, its conjugate base, and the bronzyluric base and its conjugate acid in each of the following equations. So you're just labeling which one is an acid base and its counterparts conjugate, and come back and check this video. And here is the key. Notice that on the first two, water reacts as a base, and this water on this particular equation reacts as an acid, and that really depends on the counterparts which it's mixed with. And now same for here. Notice that bicarbonates, HCO3 minus, is a base, but then on here it's an acid. Having this ability to be a acid or base has its own special name. So they both act as an acid and base, and that name is amphoteric right here. And it refers to the species that can act as both acid and a base. So water is amphoteric and so is bicarbonate. Now it says find the conjugate acid for each of the following. I will do the first one and you try the next two. To find the conjugate acid for each of the following, you're going to assume that these are all bases because after it has gone through reaction, it becomes an acid. So these are all bases. And they're going to accept the hydrogen. Well, where is the hydrogen coming from? It doesn't come out of thin air. We're going to assume that this is because it is a base. It's in water, H2O. If this reacts as a base, then that means it's going to accept the hydrogen from that water. So if it accepts it now, it's H2SO3 plus now OH minus. Now don't worry about the charge for a moment. I just want to describe the conjugates first, an acid base, and then we'll talk about the charges. So you notice that HSO3 has accepted the hydrogen from the water. Now water has lost one of the H, becoming hydroxide, and here it has accepted one more H, so hence H2SO3. Now for the charges. Hydrogen ion is also known as a proton, and it carries a charge of positive. So if this guy that has a charge of negative accepts one positive, it becomes neutral. Because for our water, because a positive charge hydrogen has left, you have to make sure that it is coming from a neutral to a negative. So go ahead and set this up. Oh, let me quickly indicate. So this is your conjugate acid. This is your conjugate acid, and this is your base. Now, do you have to write the water and the hydroxide? Not necessarily, but I think it'll be really helpful in writing this out so that you won't be confused in the future problems. So try for these guys, these bases, and see what you get as a product. And here is the key. Let's do another learning check. Here now we have a bunch of acids here, and it wants to know find the conjugate acid for each of the reactions. So let's do the very last one, and then you can do the other two. If I were to add water in here, and these guys are acting as a base, that means they're going, as an acid, so they're going to donate its hydrogen to the water. If it donates, it's going to take out a hydrogen. And then now this becomes H3O+. This has a special name. This is called a hydronium ion. Whereas the OH minus, this is hydroxide ion. So if you look at this, this is your acid that became a conjugate base on the other side. Notice because one of the hydrogen left, the positive charge left, so you will go down in charge, so -2. Hydrogen was attached to water, so because it's bringing in the plus, it becomes plus. So try for these guys and see what you get. And here is the key. There is a very last definition, which is called the Lewis definition. And the Lewis definition says that acid is an electron acceptor, it accepts electron, where a base is an electron donor. I won't go any further than this because it will pop up again in the future lecture. We'll come back to this one later.